So initially when I set up my spindle in Mach 4, I set it up so that when the spindle comes on, the pump, that fan, and this temperature sensor come on at the same time. And when it goes off, those three go off as well. And after thinking about it a little while, I think I want to change that. For example, if I have a really long job, this spindle could be running for over an hour and it might get quite hot. So it might be useful to have the cooling system stay on after the spindle is turned off. And so I think I want to change configuration in Mach 4 to add a button so that I can turn on and off the spindle cooling whenever I want. And I still want Mach 4 to have my back. Basically, if the spindle comes on, I want it to make sure that the cooling circuit is also powered up. So that's what we're going to do today in this video. I hope it's helpful to somebody. I'm going to come here to the Configure Control and then go to the Output Signal tab and then scroll down and then we'll come to the Spindle On output signal. And so I had mapped this, I had enabled the mapping. Ooh, don't want to do that. I've enabled the mapping as the check mark indicates, and then I've mapped it to the SmartBob USB, which is my PMDX 424. And then more specifically on that board, output number 1. Every time the spindle comes on, I want that output to turn on, and when every time the spindle goes off, I want to turn it off. And so that's the way it currently is. So I want to change this. So I'm going to unmap this. And I think I'll take this label. And I'm going to keep this mapping in on, or this signal on, because I'm going to use it within the Mach 4 code, the Lua code, but I'm not going to have it mapped to anything. I'm going to go up here and I see that output number 0 is available. So I'm going to enable that and then map that one to output number 1. And so just a note, so output number 1 is what the PMDX or the SmartBob, that's its name for this output. It's basically a pin on the board itself. And now we're just mapping it within Mach 4. And so Mach 4 only knows this as output number 0. It's not going to know anything about this output number 1. So we'll just have to remember that, output number 0. All right, and let me put that label back over here. All right, and so we'll save that. And then we're going to go straight into the screen editor. So operator, edit screen. And now we're in the screen editor. And so this is the piece of real estate I'm targeting. So I want to put an LED indicator button that will indicate the state of the cooling system, and then a toggle button that I can turn it on and off. And so I'm just going to select this, and it's going to open up in this tree manager that item. And so basically this thing is over here. And what I want is I want another sort of group label like this. It says spindle. I'm going to say spindle cooling for mine. And so I want that to live inside of here. And so I've selected it here. If I select somewhere else, basically wherever you select in the tree, when you click on one of these icons up top, that's where it gets inserted. So you want to make sure you're selecting where you want to be. So I want to be in the group spindle. And now I want to add another group to it. And so I click it, and now I get a group. And then you can see here it draws this square, and that square is at the origin of its parent, and its parent is this group spindle. So it's up in the corner, so that kind of makes sense. And so let's come down here and give it a better name. It's spindle cooling. All right, and then we'll give it a label, same deal. And then you can see it's not really great at refreshing, but it's overlaid that there. So let's try to move this down. So I'm going to add, so I've moved it down. Maybe I'll move it over. And so it's not great about refreshing. So the thing I've learned to do is just to minimize and then come back, and then it sort of refreshes. So it's not too bad. I'm not going to waste a lot of time tweaking this. I think that will be good. So now I want to add the LED button and the toggle button to that group. So making sure I'm selecting the spindle cooling group and not something else. I'm going to add the LED and then selecting the group again because I'm going to insert the button. I insert the button. And so now I have an LED and a button, and they're kind of sitting on top of each other, so it's lovely. So let's change the name. I keep following their naming convention. They named the type of widget in the first letters, so I'll leave that, and we'll just call it LED spindle cooling. I want to map the LED to the signal of output number 0. Once again, that's Mach4's name for the output signal that we mapped in the other screen there. And for color, I think I'll have green and red, so it'll switch between the two. I think I'll move this down a bit, something like that. All right, and so now let's go update the toggle button. Yeah, you got to be real careful in editing these fields. You have to be careful what you click on immediately after. So hitting enter usually is the best policy because then it updates. But if I were to edit in this field and then instantly click somewhere else, it will take that edit and put it in crazy random places. You know, okay, it'll put it wherever you clicked, but most likely you will not be expecting that. All right, so let's see. We'll move it down. And then on text up, we'll have on. Text down, we'll have off. So that's sort of the text within the button. I think I'll make it a little shorter. Not that short. Okay, so let's do a refresh. Yeah, so not the greatest alignment, but that's good right there. All right. So now on to the coding. So there's a couple different ways to get to the screen loading script, but this is the way I've been doing it. If you select the top level here of your screen profile, you'll see down here in the properties there are 3 buttons: properties, events, and lock position. And so if you click the middle one, the first row is the screen load script. And if you click the row, you'll see the ellipsis. And if you click the ellipsis, it'll open up the screen load script in the Zero Brain Studio. And so I think I'll probably do another video if people are interested of code organization in Mach4, because I think it's one of the most confusing things that it's just unclear why are there so many files, where do they live, and what's going on. And so right here, this is a temporary file that the Zero Brain Studio has opened up. And when you save it, it actually gets merged into this screenscript.lua file. And so I don't know if you can see here we start with page ID on the top, and then down at the bottom, I think the last line is button enable function is being called. And so that entire block of code, this whole file, is inlined here in this final product of the screenscript.lua, and then here's like the end of it. And so there's actually several of the scripts that are listed here actually get merged into that file. And so it's just something to be aware of, and I would not edit the screenscript.lua file directly here, because whatever changes you do make will get overwritten if you're using the actual GUI's method of doing things. So let's just follow their lead, and we'll use the temporary file, and when we save it, it'll get merged in. So the thing we're going to be focusing on in the screen load script is what they call the signal library. And this is a little data structure. I think for demonstration purposes, I'm gonna just collapse all these. And as you can see here, we're starting with the curly brace and ending. This is basically just a Lua table. It's basically, you can think of it in this case as an array. So we're just making an array, and then each element of the array is actually a function. And more specifically, it's an anonymous function. And so these functions don't have names. You don't declare them like function, print file. They don't have a name, so we just call them anonymous. And here we're actually just creating a function and inserting it into an element in the array, and the index of that element is actually the name of the signal we're interested in firing this behavior for. And so as you can see, there's quite a few. Not all of them have bodies, and some of them are commented out. I don't know why that is. This was one I believe I put in so that whenever input signal 8 changes, I'm going to fire this function which I created, which was check the fault VFD for a fault. And so, for example, here, at the top level, this function will fire every time that the output signal for machine-enabled changes. Whenever this signal changes state, this function here, which begins right there and ends at this end statement, that block of code is going to fire. And so each one of these takes the same argument, state, but when it gets passed in, that state contains the value of the output signal. So in this function, it's going to be the output signal. It's going to be the current state of the machine-enabled signal. In this one, it will be the current state of the input signal, input 0, and so on. And so this state is always, it's the same name of the variable, but it has it's different value in each context. And so here, if the state, meaning the current state of the machine-enabled signal, is 1, which means that in this case, the machine is enabled. And so we don't know what state it's transitioned from, but we do know that since we've been called, the state has changed, and the current state is whatever's in this state variable. So if it's 1, then run the VFD fault check. And if it's not, you can run these other 2 lines. Basically, these 2 lines will run always whenever there's a state change for this machine enabled. So that's basically the gist of it. Since this is a list of items, you can kind of see, if I expand more than one, that basically there's comma separated. So we're going to add a new one, so we need to add a comma here. If we don't, bad things will happen. And then we want to react to the output signal named spindle on. And so the code completion is helping me out. And so we want to change the state for output signal 0, but we want to trigger this function to run every time the state of the spindle changes. So it's either going on or going off. Or, if there are other states, then that's this will fire as well. And so same thing, we will take the state parameter, and then I'm just going to write the end here before I forget. And so I only want this function to run, or at least I only want to turn on the cooling when the spindle is turning on. And so I'm going to go if state equal 1. And then what we want to do is obviously change the state of output signal 0. And so in order to do that, we'll need to get a handle for it, and then change the actual signal itself. And so if you're not familiar already, in your Mach4 hobby directory, in the documents or docs folder, there should be a Mach4 core API charm file. And so this is basically the document for the documenting all of the various code calls. And so in the signals directory, we'll see the 2 functions that we're going to need. We're going to need signal get handle and signal set state. And so in order to set the state, we'll first need its handle. And so we'll make this call first. And so it shows you some C syntax. It'll show you also some Lua syntax. It'll describe what the function does, and then the parameters it takes here, and what return codes it might produce. And so it'll probably return an integer, and then these integers are enumerated in these constants, which give them value, meaning, at least to us. And so it could return no error, or invalid instance, or signal not found. And so, as you can see here, this function returns two items, and the first one is the pointer in memory to the signal handle, and the second one is that return code. You don't have to interrogate the return code if you don't want to, but it's available if you need it, and that's helpful. So anyway, so let's go MC signal get handle. We'll need an instance of the machine, and so this instance actually is a constant that's assigned up here, so that's available to us. And then the second will be the sort of human readable output names. So these are constants. Under the hood, they're probably integers of some type, and they're very useful, obviously, for us when we're coding. But at runtime, each output is going to have a different pointer in memory. Basically, every time the program runs, that pointer would be a different value, and so that's essentially what this function is doing for us. It's getting that pointer in memory, and so I'll output 0 and RC. So those are the two items returning from that function. And so now that we have the signal handle, I'll call the other function, which is really the one we wanted, which is signal set state. Yep. And here we pass it the signal handle we just got. And we want to have it set to true, which is on. And so that's essentially it. I should note, you should be aware that Lua's will give you enough rope to strangle yourself. So for example, if I change the case here of this S, these two variables are now not the same, and it's very sheepishly trying to tell me that by providing an underscore here. And also, if I double click this variable, it's not highlighting this one. It's an indication that they're not the same variable. And so it's the kind of thing that if you do it and don't see it, you'll pull your hair out for days possibly trying to see why your code doesn't work. And so just pay attention to that in your in this GUI. It's not the greatest tool in the world, but you gotta use what it's given you. And so another thing is, if I make that typo and then I go up to here, project compile, it'll compile just fine. Everything's fine as far as it's concerned, but at runtime, it will not know this method to set the state of that signal will fail, and you'll be left wondering why. And so that just gets to another point, is that you should just get in the habit of running this compile step here, because you want to know, in most programming, you want to know about your mistakes as soon as possible. At compile time is usually the best. You don't want to have to wait till runtime to know that something blew up. And so here I forgot to put the last end, to close this function out, and it's, the compilation failed, which was nice, and it's pointing me to line 88. So that's not so useful, because the mistake happened a little higher up. But we got to use what tools we have, and so yeah. So anyway, make your compile it here and make sure you get a successful compilation before you save and go back, or you'll just be spending a lot of time pulling your hair out. All right, so that's pretty much it. So now we have this function is going to run every time the spindle state changes, and if it happens to change to an on state, we're going to turn on the output signal 0, which will turn on our cooling relay. So I'm going to save this and close out and go back to the screen editor. And when you go up here to operator edit screen, this is the way you should back out of the screen editor. If you just close this, I'm not sure the behavior. It will probably have saved that code, but nevertheless, just toggle out of here. And it'll ask you if you want to save. You go yes. And then when this screen loads again, that whole screen load script is going to be interpreted. And if you have any syntax errors, you're going to know about them here because you'll get a dialog and pop up. So you definitely want to have taken care of that in the editor. So I guess now we see if it actually works at runtime. So here on the left side we have Mach4 running, and on the right you should be able to see the machine itself. So right now the Mach4 is disabled, and I believe, yeah, that the outputs are disabled as well when Mach4 is disabled. So if we click on the spindle cooling button, the LED indicator seems to change state, but nothing actually happens to the cooler. The temperature sensor doesn't come on, and thus the pump also is on the same power, so we know the pump's off as well. Alright, so now if we enable Mach4 and then turn on cooling, we see that the temperature sensor starts to boot, which is good. That's what we wanted. Let's see if we can turn it off. We can turn it off as well. Alright, you can also see how long it takes that temperature sensor to boot up. It's probably another good reason to keep it on. Alright, so let's why don't we turn it on and see what happens when we disable Mach4. I think it'll turn off, but let's see. Alright, yep, sure enough. And then if we re-enable, it comes back on. So that's good to know. It's sort of preserving the state, even if it's when it's disabled. So let's turn it off now and submit a spindle command. So let's tell it to turn on, and hopefully the cooler will come on as well. And good. So we see the spindle spooling up as well as the coolers coming on. Now we'll tell it to stop. And good. So the spindle stops, but the coolant stays running, which is what we want. And so let me see. Let's turn it off, and then I'll submit the same command but to run backwards, just to make sure that that's working. Good. It comes back on. Cool. Alright, well, that's it for this one. I guess I'll judge by the popularity of this video as to whether this is useful and interesting to people. I have no idea what people's Mach4 coding ambitions or capabilities are. So, anyway, thanks for watching.